Welcome to all. I am going to discuss about vapor compression and vapor absorption refrigeration system. Here the vapor compression refrigeration system uses a liquefiable vapor as the refrigerant. In this system, the main parts are compressor, condenser, receiver, throttle valve or expansion valve, evaporator. These are major components of this vapor compression refrigeration cycle. This schematic diagram is shown in the figure. A vapor compression refrigeration system uses a liquefiable vapor as the refrigerant. In this system, the main parts are compressor, condenser, receiver, throttle valve or expansion evaporator. The compressor in the system increases the temperature and pressure and changes the phase of the working fluid, which is put input power to the system. Working fluid is then passes through the condenser, which transfer the fluid heat to the surrounding, keeping pressure constant. The high pressure fluid is collected in the receiver. The fluid is expanded using throttle valve, which reduces the pressure of the fluid. Immediately the fluid passes through evaporator. The evaporator is part which absorbs the heat from the surrounding to make the fluid boil, which phase changes back the fluid to initial condition. The vapor compression refrigeration cycle consists of 4 processes. The process from 1 to 2, isentropic compression of saturated vapor in the compressor. Process 2 to 3, the constant pressure heat rejection in the condenser. Process 3 to 4, throttling of refrigerant in the expansion device. Process 4 to 1, constant pressure heat absorption in the evaporator. The refrigerant enters the compressor at the stage 1 as dry unsaturated vapor, where it is compressed to a relatively high pressure and temperature to a stage 2. The refrigerant in the superheated state 2 enters the condenser and leaves as a saturated liquid at state 3 as a result of heat rejection to the surrounding. The saturated liquid refrigerant at state 3 is throttled to a evaporator pressure by passing through expansion valve or a capillary tube. The temperature of refrigerant at the stage 4 drops below the temperature of the refrigerated space. At the stage 4, refrigerant has wet mixture and passes through an evaporator at a constant pressure. A refrigerant is completely evaporated by absorbing its latent heat from the cold temperature space. The heat absorbed during the evaporation of refrigerant is the latent heat and its magnitude is higher at low pressure. The only throttling process 3 to 4 is an irreversible process. The remaining 3 processes are considered reversible. Therefore, the vapor compression cycle is not a reversible cycle. The advantages of vapor compression system has high value of coefficient of performance. It approaches reversed Carnot cycle except for expansion of refrigerant in expansion device. The size of refrigeration system per ton of refrigeration is smaller. It has less running cost. Disadvantages of this system is high initial cost and leakage of refrigerant may cause harmful effect. Finally, the production of some refrigerant may be hazardous to the refrigerant. And now we are going to discuss about vapor absorber refrigeration system. In a compression refrigeration cycle, the temperature of saturated vapor leaving the evaporator is increased by compression process. Since the specific volume of vapor is relatively large, therefore the input work to the compressor is also large. The input work to the compressor can be reduced significantly if the refrigerant is compressed at a liquid state. The absorption refrigeration system is based on this approach. The vapor absorption system operates with a condenser, a throttle valve and an evaporator in the same way as vapor compression system, but the compressor replaced by absorber pump and generator unit. The low pressure refrigerant leaving the evaporator is absorbed by a second substance called as absorbent to form a strong liquid solution. The figure is showing that vapor absorption system of refrigeration. This liquid solution then pumped at high pressure to the generator. The specific volume of the liquid solution is much less than that of a refrigerant vapor, and the significant less work is required in the pump. The heat is applied in the generator where the refrigerant vaporizes from the solution and leaves the weak solution in the generator. The refrigerant vapor enters the condenser and the weak solution is again sent back to the absorber through a pressure relief valve. The coefficient vapor absorption refrigeration system can be expressed as coefficient of performance is equal to heat absorbed in evaporator divided by heat input in generator with heat pump work. Thank you for watching. In the next part is going to explain about this continuation. Within this I will conclude. Thanks for watching.